Hello everyone, how are you? I'm fine here and I hope you guys are also fine over there. I think this pandemic situation is going for long than we expected, and I want to suggest that please focus your focus yourself to the study and many more new research things in this free time, so that you can properly exercise your brain in this free time. So after 4 or 5 days I have came here again in this video, and there were so many questions asked in our group e-PCM 2077 over these 4 or 5 days, and most of those questions have already got the solutions through different students in their comment sections. However, I find 3 questions that were stuck in our group, and no solutions has been posted for those 3 questions. So I am directly going to solve those 3 questions in today's sessions. The 3 questions are already asked by Vivek Pandey and Kavi Joshi, among which one question is asked by Vivek Pandey, which is from sequence and series, and another 2 questions that were asked from integration sections by Kavi Joshi. So let us solve the questions from sequence and series at first, which has been posted by Vivek Pandey. So you people can see the question in this upper part of the video. So I directly want to move through the solution of this question. So the conditions are given conditions are modulus of x and modulus of y are less than 1. So we have to find sum of series. So what is the series? X plus y plus x square plus xy plus y square plus x cube plus x square y plus xy square plus y cube, and term to the infinite. So when I go through these terms, I find one similarity, that when I multiply this term by x minus y, the result will be x square minus y square, and when I multiply this term by x minus y, the result will be x cube minus y cube. Similarly, when I multiply this term by x minus y, then the result will be x to the power 4 minus y to the power 4. So we can simplify this as, we can write these terms as x square minus y square divided by x minus y. Similarly, this term is x cube minus y cube divided by x minus y. Similarly, this term is x to the power 4 minus y to the power 4 divided by x minus y, and the terms up to infinity. So I can take x minus y common from here, and I can arrange the term containing x in one place and another term containing y in another place. As I have already changed the sign, as y square y cube y4 is positive, so we can replace this plus by minus over here. So again, as this is question from infinite geometric series, so I can take x square common from here, so it will result into 1 plus x square and terms up to infinity. Similarly, I can take y square common from here, it will result into 1 plus y square and terms to the infinity. So as the common ratio, first term is 1 and the common ratio is x. Similarly, here first term is 1 and common ratio is y, and according to the property of the infinite geometric series, the absolute value of the common ratio should be less than or equal to 1, which is already given in the question. So I can directly write x square times sum of this series is 1 by 1 minus x. Remember, the sum of the infinite geometric series is a upon 1 minus r. So here is first term is 1 and common ratio x, minus y square times, what is the sum of this series? In the same manner, sum of this series is 1 minus 1 by y. So I can write 1 by x minus y, x square 1 minus x minus y square 1 minus y. So 1 upon x minus y into, let us simplify this expression. So this expression will result into x square times 1 minus y minus y square times 1 minus x upon 1 minus y upon 1 minus x 1 minus y. So 1 by x minus y into, so I can arrange this as x square minus x square y minus y square plus x y square upon 1 minus x 1 minus y. So 1 minus 1 upon x minus y. So I can directly like x square minus y square can be written as x minus y x plus y. Similarly, we can take xy common from this section, this term and this term. If we take xy common from this section, then x minus y will be the result. So 1 minus x 1 minus y. So this will result into 1 upon x minus y into, I can take x minus y common, and the remaining term will be x plus y minus xy, 1 minus x 1 minus y. That means x minus y gets cancelled and the result will be x plus y minus xy upon 1 minus x into n minus y, which is the required sum of the series. This question is very good question, but a little bit lengthy. However, from the practice perspective, you people have to practice this type of questions, which will surely sharpen your mathematics problem solving skills and also makes you people capable of facing different types of challenging exercises in mathematics. So I am moving towards the second question, which is asked by Kavi Joshi, and that question, as I have already told you, that question is actually from integration section. You people can see the questions in this upper part of the video, and the first question is 2 e to the power x plus 3 by 4 e to the power x minus 2, and whose integration is to be determined. So whenever I see these questions, there are the terms e to the power x in the both numerator and denominator, and we know the derivative of the term e to the power x is e to the power x itself. So this formula can be arranged in terms of log. Remember integration f dash x by fx dx else log of fx. So first of all, I am going to arrange this as 2 e to the power x plus 3 by, I am making 2 e to the power x in the denominator, so I am taking 2 common from the denominator, and I will get 2 e to the power x minus 1. So I will arrange the numerator in this factor inclusion form, that is 2 e to the power x minus 1. So to get 2 e to the power x plus 3, I have to add 4 by 2 times 2 e to the power x minus 1, and I can arrange this as taking only this term will else integration of 1 by 2, and taking the latter term will get 2 times 2 is 4, so integration of 2 by 2 e to the power x minus 1. So I can directly write x by 2 plus I can take 2 common, so 1 by 2 into e to the power x minus 1 dx. So to integrate these functions, I can perform a very small mathematical operation, that I can write this as 2 by e to the power minus x minus 1, and I can arrange this as x by 2 plus 2 times e to the power minus x by 2 minus e to the power minus x dx. So the derivative of e to the power minus x can be arranged in the form of e to the power minus x. So let y equal to 2 minus e to the power minus x. This will else dy equal to, so derivative of 2 is 0. Derivative of e to the power minus x is e to the power minus x into minus 1. That makes that minus 1, and this minus 1 will make plus 1. That is e to the power minus x dx. Are you getting this? So e to the power minus x when performed with derivative differentiation with respect to x, else e to the power minus x into minus 1, and that minus 1 when multiplied with this minus 1 will yield plus 1, and the result will be e to the power minus x dx. So x by 2 plus 2, I can write this as e to the power minus x dx is actually dy by y. So x by 2 plus 2 log y plus c. However, the y we supposed here is 2 e to the power minus x plus c. So this is the actual answer of this question. There are no options posted by Kavijoshi in this question, but you can arrange these answers in another form as well. That is, or x by 2 plus 2 log 2 minus 1 by e to the power x plus c, x by 2 plus 2 log 2 minus 2 ex minus 1 by e to the power x plus c. Also you can arrange, yes, this is the form, this is in the form of log a by v, so log a minus log v as well. So this is the answer of another questions that has been stocked in our group and get no solutions in these 4 or 5 days. So I am moving towards the third questions, which is similar to these questions and also from integration and concept wise this is almost equivalent to this question. So let's move towards the another questions. So third questions is very similar to the questions that we have performed solution just before this questions, and the question is integration of 3 minus 3 e to the power 5x by 4 plus 6 e to the power 5x dx. Again, I am observing the term e to the power 5x in both numerator and denominator. So the derivative of e to the power 5x with respect to x will be 5 times e to the power 5x. That means we have to arrange this denominator in the form of what? Numerator to perform integration at first. So I am going to make this term as 3 e to the power 5x, as I have 3 e to the power 5x over here in numerator. So 3 minus 3 e to the power 5x, if we take 2 common from these two terms, there will be 2 plus what? 3 times e to the power 5x dx. So similarly, I can get this term in the numerator by performing simple algebra, that is 2 plus 3 e to the power 5x. Remember, here is minus, so it is better to take minus over here. So that will else minus 2 minus 3 e to the power 5x. So minus 3 e to the power 5x is already appear in here, and we have to find we have to go through any mathematical operations to get plus 3. As here is already minus 2, so I can get plus 3 by adding 5. So 2 plus 3 times e to the power 5x dx. So I can again arrange these questions in the form of 2 factors. That is, one is this first term by the whole denominator, and the second is this second term by the whole denominator. So when I arrange this question in that format, then I will get, let's write from the back side. So 5 by 2 times 2 plus 3 e to the power 5x. The first term is, actually I have written the second term of the and this format is in first term here, so don't be confused. And the second term will be taking this factor. Second term will see this minus integration 2 plus 3 into e to the power 5x by 2 times 2 plus 3 e to the power 5x dx. In the same manner as in previous question, this term will get cancelled. That means, so we can take 5 by 2 common, and the term we will get will be 2 plus 3 times e to the power 5x dx, and we will get straightforward this 1 by 2 dx. So now we again have to perform integration of these functions. Remember, whenever there is the term e to the power nx in the denominator, then it is always better to solve those types of questions by making that e to the power nx in the form of 1 upon e to the power minus nx. So 5 by 2, what I can write here is 2 plus 3 divided by e to the power minus 5x, and this is x by 2. And again this will be 5 by 2 e to the power minus 5x by 3 plus 2 times e to the power minus 5x dx minus x by 2. So again, let y equal to 3 plus 2 times e to the power minus 5x. So what will be dy? So dy is equal to derivative of 3 with respect to x will be 0. This 2 will remain as 2 as it is a multiplying factor to this function, and the derivative of e to the power minus 5x is actually e to the power minus 5x into minus 5 times dx. So we can directly write what e to the power minus 5x dx is equal to e to the power minus 5x dx is equal to 5 to the 10 minus 1 by 10 dy. So I can write these questions as now 5 by 2 into minus 1 by 10, so dy by y. Are you getting this? I just took minus 1 by 10 out of the integrating function as it is constant, and e to the power minus 5x dx is actually dy when I took minus 1 by 10 outside from this integrating function, and the denominator here we have supposed that denominator is y, so I can write y minus x by 2. So 5 times 2 is equal to 10, that will else minus 1 by 4, and it will gives log y or log to the base e, or you can simply write ln y minus x by 2 plus c. So minus 1 by 4, so the y appearing here is actually 3 plus 2 times e to the power minus 5x. So log 3 plus 2 times e to the power minus 5x minus x by 2 plus c. Remember the questions, these three questions are I would not say tricky questions, but these are actually creative questions. You have to think a lot in these questions, and you have to be creative to solve these questions. These types of questions are very better for practice purposes, but I think from entrance perspective these questions will be a bit lengthy, as we have to perform the solutions of any 2 marks question within 1 minute and 30 seconds, and it is almost impossible to solve these questions in that given time frame. So but you will learn so many basic concepts from this question, like the major concepts is whenever you have the integrating functions such as constant by something algebraic expression of summation or addition, summation or subtraction involving e to the power nx, then these types of questions are always solved by expressing those e to the power nx in the form of 1 upon e to the power minus nx, as we have done in these 2 questions. So please solve this type of questions in these free times as well, because this will sharp your minds very much, and you can tackle many more questions in coming time period for actual entrance examinations period. So this much for today. Thank you everyone. And at last, please, I have just started these types of procedure just one week or 10 days ago, so please subscribe my YouTube channel. I am thinking big on my channel, as in coming time I am going to put a lot of lectures from mathematics and physics. I am thinking about that as well, so you can subscribe my channel. Please tell your friends to go through these videos and subscribe it as well. Thank you.